Hey friends, in today's video we're going to be talking about the furnace control board. And isn't it true when you go up to a furnace, at times it can be a bit intimidating when you look at the control board and see all the wires coming out, going throughout your furnace? But hopefully by the end of today's video, as we compare the control board here outlined on this whiteboard, see what each wire does, and comparing that to the actual control board using our meter, it'll give you better confidence on how to troubleshoot your next heating call. All right, so I want you to start off by looking at this lion, this beast head on, this control board. It has nothing on you. Yes, you see a lot of wires staring back at you. It could be a bit intimidating, but we're gonna go over every single wire and you're gonna see how easy it is to troubleshoot furnace control boards. But it is important to kind of just lay out briefly what's going on. We're gonna be going to the whiteboard in a bit, but just I wanna lay out all the wires and what is going on right here. Okay, so of course, power. We begin with power coming in. This is your pigtail right here. This is 120 volts coming from your outlet, right? So you gotta connect that to an outlet so you can have power coming in. And then if you follow this carefully, at least the neutral wire, that neutral wire goes all the way to the neutral party. I call it a party because once you put that neutral coming from the pigtail here, everything else that you connect, it also is getting neutral from the main neutral coming from the pigtail. So it's coming to this neutral bar right here. It's like a little neutral party. And then my hot, my 120 volts comes to the door switch here, right? It comes to the door switch in here. And then when it gets pushed in, it allows 120 volts to come out. And if you were to follow that, it goes right there, right here. Okay. And you can tell that it goes there because it literally tells you right there, line 1, 120 volts. Okay. So that's where 120 volts comes from your pigtail. Your neutral goes boom, home run to the neutral party. And then my 120 volts goes to the door switch and then it gets pushed in and then boom, comes to line 1 up here. Okay. All right. So let's continue. So we have our inducer draft motor. So if you were to look at that inducer draft motor, look at my neutral. Guess where that neutral goes to? It goes to all the neutral parties there, right? If I were to pull this wire here, you see I'm pulling it and it is this one right here. And yep, it goes to all the neutral parties. So that's neutral. The black one right here, right? This black one, my 120 volts. When I pull it, it's going right here to this bottom one, okay? And we'll explain that right now in a bit. I'm just trying to point out all the wires to you so you can see where it goes to on the whiteboard. My pressure switch, you got a yellow and an orange wire, and it comes right here to this Molex connector. And let me try to get it out right there. You see that? Orange and yellow pressure switch, okay? So we've taken care of these wires. What about my gas valve? You got a blue wire and a green with yellow. If you were to follow that, it goes right here. My blue wire is over here, okay? And then my green and yellow, it's gonna be this middle one. You see how it's yellow there and green over here? So this one here is the common going to my gas valve. Okay, and then we have a lot of safeties, right? Bunch of red wires everywhere, right? And then I'm gonna show you a little pro tip on how to find out if your circuit for your safeties are all closed, but they're all, red wires. So with these, it goes right here, the 2 red wires right there. And this is gonna be very important when troubleshooting, and we'll go over that in a bit. And this is my hot surface igniter. You see that neutral right there? That neutral, guess where it goes to? To all the neutral parties, right? That neutral goes right there. And then this hot one, the 120, it goes right here to the top one, right? So the top one is hot surface igniter. This bottom one is the inducer draft motor. And then my flame sensor, which is a white wire for flame rectification, it goes all the way right there to this white wire. So this harness plug is important, and we're gonna break it down so you can understand it. Okay, so we've gone over all these wires. So then we got a transformer. So this is important right here. My blue and my red is my 24 volts. If you look at that, it goes right there to where it says secondary 1 and secondary 2. So secondary 1, that's hot, 24 volts, and then my common is the bottom one, secondary 2. Okay, now for me to get 24 volts coming out of the transformer, I need to be coming in with 120 volts. So where do the black and white go to? Well, if you guessed it, if you said white goes to the neutral party, you guessed it right. If I pull this, it goes to all the neutrals, right? My neutral party, my neutral bars here. And then my hot, if you follow it, it goes right here. Let's see if I can, right there. PR-1, it is this one, okay? So we'll talk about that right now in a bit, but simply put, my 120 comes here, between this one and up here, there is continuity. So I am supplying 120 to my transformer, okay? And then what else? Of course, you got your blower motor speeds. This neutral, guess where it goes to? To all the neutral parties. And interestingly, the neutral blower motor, for some reason it says BLW blower motor, but I've already tested it. If you were to connect it in another one, it would work just fine. But I guess they did put BLW blower motor, so just, you know, put it there if it tells you to put it there. You see, blower motor. So that's, and then the speeds right here, right? The speeds that you're not using, you're basically parking them. And what I mean by park, it literally says they're spare. So you're just gonna plug it in and it's just there. It's not doing anything. And then the ones that you are using for cooling and heating, the speeds, for cool, we're using the black wire, and for heating, we're using the blue one. And we'll go over that right now in a bit. And that's basically it. We went over all the wires. Now we're gonna go to the whiteboard, go over the control board, see what each one does and how the sequence of operation works. And like that, it gives you a better idea as to how the furnace works. All right, so I'm not gonna be going over the sequence of operation of a furnace. I do have 2 videos on my channel that go over the steps. But if we were to just simply state the steps, I use an acronym called TIP-BIG-FB to understand the sequence of operation for a furnace. So it starts off with the thermostat. There's a call for heating. W receives 24 volts from your R, from power. And then your inducer draft motor receives 120 volts. It pulls a suction pressure, a negative pressure. Your pressure switch closes. And then 24 volts goes through. My board, my safeties. These safeties have to be normally closed, and we have high limit and flame rollout. Now, technically, this one is supposed to be before the thermostat, because if any of the safeties are open or they trip, thermostat won't receive power. And that's going to be important right now as we go over. But I put it here because it just kind of makes sense with the acronym. After that, ignition, hot surface igniter receiving 120 volts, or it's a spark igniter. And on this one's going to be a hot surface igniter, at least for this specific furnace. And then your gas valve receives 24 volts. And then you get flame rectification through your flame sensor. And then your blower motor receives power and it turns on. Okay? So we kind of went over what goes on the control board. We're now going to specifically go over not so much the sequence, but more how things turn on with the control board. That's what I want to accomplish with the video, okay? So if we get a little closer here, and we're going to have to go back and forth, okay? But the first step, right? When I have a call for heating, right? What happens? Your thermostat, right? Because these go to my T-stat, basically R, right? Gives your W power. Once W receives 24 volts, okay? Once W receives 24 volts because you have a call for heating, up here, right here, if you recall earlier, I showed you the 2 little relays here. Let me show you again the 2 little relays right there, right? These are just switches, right? Okay, 2 switches, 2 wires, right? So once W receives 24 volts, internally, right? Internally, and you see right here, line 1 power, right? Coming in. Internally, line 1, the little switch between line 1 and your inducer draft motor closes, and it sends 120 volts internally through the back of the board like that. Boom, because this is basically a switch that's open, right? It is a switch that's open. So boom, inducer draft motor turns on, right? It turns on, it pulls a negative pressure. So my pressure switch if you recall, it has the blue, an orange rather, and a yellow one. So orange and yellow. So what I did right here is I used this one, orange and yellow, right? Pressure switch. So then you have 24 volts coming out, and I guess I'll put it like this, right? It comes out that way, and it goes to your pressure switch. If that pressure switch closes because it senses a negative pressure, then it makes it back, and then it receives 24 volts. And now we can go to the next step, okay? And then your ignition receives 120 volts. So once your pressure switch is closed, guess what happens right here in line 1? With line 1, now you also have power going to this switch right here that is open. So once your pressure switch closes, boom, it sends 120 volts, right? It closes to your hot surface igniter for a couple of seconds. And then my gas valve receives 24 volts around that same time. And where is the gas valve wires coming from? It's right here. And at least in this specific one with this Molex connector, it is going to be this one. This is my 24 volts. And that is my ground, my common, right? So when I follow the blue right here, the blue and the green one in there, in the middle, it goes to my gas valve. So then it sends 24 volts, and then you get flames, and the flames hit the flame sensor. That's all the way. Let's see if you can see it in there. You see that flame sensor? Let's see if I can get a good picture of it. It's gonna be right there. You see that flame sensor right there, a little L bracket right there? That one, you have 80 to 100 volts here. Once the flames hit that flame sensor, you're basically completing the circuit. And if you follow the white wire, it goes to this last one right here, right? The last one. And that is why you need a good ground going to your furnace. But this is my flame sensor, okay? So, so far, we've kind of identified all the wires already, right? My gas valve, my hot and my common, my pressure switch, right? These two, and then my flame sensor for flame rectification. We're gonna go over this. If there's anything you're gonna learn from this video or something that it's gonna you're gonna benefit from, it's gonna be this part right here, and we're gonna spend a little bit of time on that. But you were able to see that these are just switches. When it receives 24 volts, boom, 120 volts. It's already here on one side. It closes the switch, boom, sends power, and it does the same thing too with the hot surface igniter. Now, going back down here, right? 120 volts goes in here between this one and your PR-1. And sometimes you'll see XFMR. This right here, there is continuity between these two. This is where your transformer receives 120 volts because your transformer, to step down to 24 volts, it needs to receive 120. So this is where it receives your transformer, the 120 volts, right? And in this case, you see this wire right here. You see right there. I'm going to follow it. It goes all the way right there, which is PR, right? PR-1 right there. So, okay, let's see if we can get it closer. PR-1. Or you might see XFMR, like I had mentioned. And then these are just spares, right? Whatever speeds, right? Because this is a PSC motor, whatever speeds you're not using, park it right there on the spare, as we mentioned earlier. If you're not using these two wires, do not wire nut them together. You will burn that motor. So just park them there, right, on the spares. Okay? And this part here, right here as well, you got 120 volts right here. When you have a call for cooling between here, and just imagine like a switch here, okay? I'm going to put right here. I'm going to put, I guess, two switches, okay? When you have a call for cooling, right? This is 120. When you have a call for cooling, this is what it does. It just closes the switch. So then power goes from 120, it closes the switch, to whatever wire you have from the PSC motor, whatever speed you're using on the cool, that's the wire that's going to receive 120, and it's going to turn on the blower motor. When you have a call for heating, R hits W, then whatever wire you have on the heat, then 120 is going to close and go to my heating speed. So in this case, we're using the black wire for my cooling, right? If you see down there for my cooling, and then for my blue, we're using my heating. So have you noticed already? This is just a switch right here. It's just two switches, one for cooling, one for heating. Guess what right here? There are also switches. Line 1, power in. It's just a switch. Whenever there's a call for heating, it's going to send 120 at the appropriate times. Okay, so what about this one here? Neutral. This search is my neutral. It's just a big neutral party. So when I get the pigtail, right, neutral coming in here, whatever loads that need neutral, like your transformer neutral, your inducer draft motor neutral, your blower motor neutral, your hot surface igniter neutral, they all go there. So as you can see, look at all my neutrals. They're all together. They all go there. Okay. And then this right here is my secondary 2, secondary 1. So this is where your 24 volts goes to, right? My common and my hot. And then we'll talk about that right now because I really want to make a point about this right here. This is going to be very important. And then this is your little terminal strip where you connect your thermostat wires, right? Your red to your R, or for power. Cooling, which is yellow. I didn't have a yellow color. I did orange, but it's just yellow. W, white, common, and then your G for your fan, okay? All right, so this is what I'm trying to get to right here. What about these two red wires, okay? What's going on right here? Well, when you connect your transformer, right? So your 24 volts, right? This is your 24 volts. This 24 volts does not go right away to my R terminal. It does not. It does make it there, but not right away. Okay, that's important to understand that. So what happens exactly? Well, let's use Mario for an example. Mario is going to start right here. His goal is to go from here to R, okay? He's got to make it here. If he doesn't make it there, then your thermostat's not going to get power. And if your thermostat doesn't have power, how can you send 24 volts to your actions? To Y for cooling, W for heating, or for your fan? You can't. So this is important, okay? This is the path that it takes. It starts right here on secondary 1, and it goes through your fuse from the bottom and then to the top, like that. And then it continues going to pin 6 and pin 4, at least for this specific furnace. This is my Molex connector. So then it goes through your safeties, and then it comes back to my R, at least through the back of the board. But you see, to get 24 volts, to go from there to R, it takes a path. It takes a journey. And so a lot of things can happen where 24 volts will not make it to my R. My fuse can pop, or my safeties can open. Okay, so now I'm going to show you this. I'm going to show this part to you on the furnace now, so you can see that it is really all connected as it tries to make it from power to your R terminal. Okay, so this is the path that 24 volts takes. Okay, and this is important to know because when you're troubleshooting, you need to know why your thermostat is not getting power. Did a safety trip? Did the fuse go bad? But I'm gonna go ahead and confirm this for you. So look at this. I have it on continuity, right? So if I touch both leads, you see how it changes? There is a path, okay? So we start off at 24 volts, right? Because this is where my power from the transformer goes connected, right? Secondary 1. So from here to the top of that fuse, you see the top of that fuse right there, there is a path. And so let's say the fuse is good, right? The fuse is good. The path continues, right? Because from the top to the bottom, right, of the fuse, if the fuse is good, it continues, right? So once again, from the top to the top of the fuse, secondary 1 to the top. Let's get a little bit closer. Okay, secondary 1 to the top of the fuse, right? There's a path. And then the fuse, let's say the fuse is not popped, so if it's good, then the path continues. From here, this is important, from the bottom to pin 6, you see I'm getting a path from pin 6. And then from pin 4 to R, I'm getting a path. Okay, so obviously I have to put a little jumper, right? If I want 24 volts to go through the fuse to pin 6 to pin 4 and then through the back to R. But guess what that jumper is? These two red wires. That is my jumper. Now this jumper here has safeties. So we have a couple of safeties here. We have high limits and two rollouts. So when you go back over here, you see we have a path from the 24 volts going to my fuse. If my fuse is good, the path continues. And then I could technically just put a little jumper, but I would be bypassing the safeties, and we don't want to do that. But at least for this specific drawing here, I put a manual a flame rollout. And you know it's a rollout because you usually have a little arrow there because it's a manual reset. And then it goes to your high limit. And right now, of course, it is open, so the power wouldn't go through because I have to make sure I have a path there, but these are normally closed switches, okay? So what does that mean though? So if you look at these red wires, these two red wires, look how many safeties I have. I have, what is it? A rollout right there. I have a high limit right there, another high limit, and then I have another rollout. And you're like, if your system tells you it's blinking and it says rollout tripped or high limit tripped, which one is it? And is it even true? How can I confirm? Well, you can do this simple test right here. You can go ahead and get your meter, put it on continuity, okay? You see? And then all you need to do is go to your red wires. Now, if you have the skinny leads, you can go through the back, but you can also get it from here. Look, if I have continuity right now, that means that I have a path. All my circuits are closed. Look at this right here. Let's go ahead and put one right here and one right there. Okay, I have it on pin 4 and pin 6, okay? And it just takes me a bit to get this. There we go. You see, I'm getting continuity right there. I'm getting continuity. So when I plug it in, when I plug this in like that, remember what I said, 24 volts. In this case, let's put Mario, 24 volts goes through my secondary one. It goes through my fuse. Then it goes to pin 6. Then that pin 6 goes through all my safeties. So they're all normally closed. It's going to come back. It's going to come back to pin 4. And then it goes to pin to the R or terminal. So do you see how a heating issue can cause, if your rollout trips or something, it can cause your cooling not to work. So it's important to understand this. So one way is to just do continuity. If you have instead of doing continuity on every single safety, remember, it's just one wire going out, going all the way through the safeties, and it's coming back. So if you get continuity, like we saw right now between both reds, my safeties are closed, are good. Let's go ahead and do an example now, though, of a safety tripping. So I'm going to go ahead and you see right here, let's see if I can do this with two hands. So this safety right here, this is a rollout because it's got a little button here. So I'm going to go ahead and get my Molex connector here. And then let's go ahead and see if I can put this through the back. So like that, you can see that we have a path. Okay. So I'm going to leave it there. You see, right now, there is a path. There is continuity. Okay. Let's say a safety trips. Okay. I want you to see, once I trip that safety, I want you to see how that goes to open line, because now there's no path. Okay, almost there. There we go. I heard that click. You see? Open line. So guess where 24 volts is stuck at? 24 volts is stuck on this side. So Mario is not gonna make it to your R anymore because he's stuck on this side of the safety because it tripped. It's normally closed switches, so it's stuck right here. So all I have to do, and just to confirm again, open line, go ahead and reset that safety, push the button. Okay, see, now I have a path. So that is the big thing about this one. Now you know, right, how the two red wires work. Sometimes other furnaces, they have a different color, but typically you have two wires where before it goes to your R, from the fuse, it's sending 24 volts through one wire. And then if all your safeties are good, it comes back through the other wire, and through the back of the board, it goes to your R, just like we drew right here. So yeah, you can definitely isolate this and then check continuity this way. And if it's a good circuit, 24 volts should make it back over here to R. Hopefully today's video was able to give you a better idea on how the furnace control board works. If you want to go a little bit deeper more into how a furnace works, at least with the sequence of operation, I have 2 videos on my channel, part 1 and part 2 on how furnaces work. But as you were able to see, the furnace control board, every wire has a purpose. And by just using your meter and your knowledge, you're able to see that everything here has a purpose. It's gonna either turn something on or turn something off. Maybe it's just a path, maybe it's just a switch. But don't be intimidated by these control boards. And although this is just one furnace, but really all furnaces, whether it's an 80% or 90% furnace, they typically work the same. I hope that today's video helped you out, and I'll catch you on the next one.